In today's class, we are going to discuss about cells. So, our today's topic is about cells beta. Now, in the cells, so actually the cell is nothing but, we can say simple to language, battery. It has two terminals. One is positive terminal, other one is negative terminal. And every cell will have two things. One is EMF, other one is internal resistance. Here we can represent the cell symbol like this, or we can also write the cell symbol in this way also. E and small r, or simply sometimes they will write E. All these things indicates cell of EMF E, and even they didn't write here. You can notice here they didn't mention internal resistance. Even they didn't mention internal resistance, international resistance will exist here. So if you observe first one here, E comma R, EMF comma internal resistance. Here EMF and internal resistance, they are given separately like this beta. Now they didn't write here small r, but still small r is there. Still small r is there. So what is this E? Question arised. What is this E? E is called as electromotive force. Electromotive force. We'll call it as simply EMF. EMF. Its name is electromotive force, but is not a force. What is that? We'll see. And what is R? R is called as internal resistance. Internal resistance. So here if you observe, the cell means actually we will say that every cell has one cathode and anode, and electrolyte is present between cathode and anode. That electrolyte offers some resistance. The resistance offered by electrolyte, is called as internal resistance. So the opposition to flow of current through the cell is called as, inside the cell is called as internal resistance. So now what is electromotive force means? This electromotive force means the work done in moving the charge outside the cell as well as inside the cell, that is called as electromotive force. Now we'll observe that one in detail now. So these are the symbols. That means if we can write the symbol for electromotive force E comma R simply like that, or we can represent like this, or sometimes they write only capital E, only capital E. So everything indicates same. All the three are same here. All the three are same. Now let us enter. Here I am taking one cell. This is a cell means one big terminal, small terminal is a positive one, negative terminal, and here EMF, and this is one small R resistance. Now this is connected to an external resistance like that, and it is closed. This is also called as closed circuit. Closed circuit. So now coming to the what is this closed circuit? What is the phenomena happening here? We have to observe. Here the things are E is EMF of the cell, EMF of the cell, and small r is internal resistance of the cell, internal resistance of the cell, and capital R is external resistance. Capital R is external resistance. So now what will happen whenever a cell is connected, and here what is this E means? In a simple language, we can also call it as potential difference. Potential difference. But exactly the potential difference means current into external resistance we used to say. But here the current always flows from positive terminal of the cell and will enter into the resistance, and again through the inside the cell it will travel like this. So here small r actually originally very small r means inside the cell only. The small r lies inside the cell. We are representing outside, but originally it lies inside the cell. This is called internal resistance. So the potential difference in making the charge to move outside the cell as well as inside the cell. The charge is moving outside the cell as well as inside the cell in the complete circuit. For that, what the work we do in moving the charge, that is called as EMF. That is called as EMF. EMF means the work done moving a charge outside the cell as well as inside the cell. That the potential difference outside the cell as well as inside the cell is called as EMF. Now let us observe here. Let us take V is potential difference across the external distance. V dash is potential difference across the internal distance. Now, what is EMF? EMF is nothing but, I can write it as V plus V dash. Now, V is potential difference across external resistance. And what is V dash? What is V dash? This is potential difference across internal resistance. Potential difference across internal resistance. It is also called as loss volts. So the whatever the EMF we are providing here for the cell, because of EMF, the current is flowing through the cell as well as outside the cell like this. Inside the cell as well as outside the cell. So the work done in moving the charge outside the cell as well as inside the cell in the circuit is called as EMF. Here EMF is potential difference across external resistance as well as potential difference across internal resistance. Like that I can write about EMF. Now here I can write what I noticed is V is equal to I into R and V dash is equal to I into small r. In the diagram you can notice that one. Here, what is the potential difference here in external resistance means V equal to IR. What is the potential difference across internal resistance? V dash is equal to I into R. So potential difference across external resistance plus potential difference across internal resistance is nothing but EMF. So V I can write as IR. V dash I can write as I into small r. I am substituting in this equation. I am substituting now. Let us check it out that. So here E is equal to what we told just now. E is equal to, as E is equal to V plus V dash. We can write now E is equal to IR plus I into small r. So now I can take I common and I am sending the things other side. I can write I is equal to E by R plus R. So current in the circuit is nothing but EMF applied by total resistance. In Ohm's law also, in Ohm's law, I is equal to V by R. Here V is nothing but V is corresponding to U. Here R net we can take total resistance. Total resistance is external resistance plus internal resistance. So total external resistance plus internal resistance is the net resistance. V is potential difference. Here we are supplying through EMF. So what is the difference between potential difference and EMF? I can say simple way, EMF is the source and potential difference is effect. Potential difference is effect and EMF is source. Like that, I can explain the potential difference and EMF relation. Potential difference is the effect, EMF is the source. Both are same, work done in moving charge only. But the source which we are calling as a EMF and the effect of that source we are calling it as potential difference. Now I hope you are clear with this. I is equal to E by R plus R formula. Now from this, I can also observe this one like this. V is equal to what I know, V is equal to I into R. This is one point, important point beta. V is equal to IR. I can write it as E by R plus R into capital R. So now the formula for V and R in terms of EMF and external resistance Here what we got here, without naming I can write like that. If I shuffle the terms, just I cross multiply. Suppose I taking this one this side and cross multiply and simplify. I can also write this one as R is equal to E minus V by V into capital R. Just you can cross multiply, and if you simplify, you will get this expression. This one you have to check it out. How you got this one? Very simple. Just to cross multiply the terms and get the value of small r. Small r, you will find this one. Like that also I can write. Now, here the expression what I am writing here is, I am taking the R is equal to E minus V by V into R I have written. And already I told you that E is equal to V plus V dash I told. Here, V dash value is equal to, V dash value is equal to, I told it as I into small r. This is last words. So E is equal to V plus IR I can write. So V is equal to E minus IR. So here V is equal to E minus IR I am writing. This is the equation. This equation I can also write. Discharging equation. Discharging equation. Discharging equation I can write this one. So when our discharging case, because battery is connected and is a closed circuit, it is a discharges. The battery will be going on discharging. The potential difference formula is E minus IR. V is equal to E minus IR. So this is a discharging situation, and I can write like this. V is equal to E minus IR is my expression. I hope this is clear for you. Whenever I am taking a closed circuit, what are the main points to be noted? I will give you again that information. Whenever you observe closed circuit, closed circuit means here the main points are, first of all, diagram of the closed circuit I have given like this. This is external resistance and this one is internal resistance, capital R, small r, EMF E, potential difference across here is V, V dash, and current is flowing is I. Current always travel from positive terminal to negative terminal. So what are the things we noticed? I is equal to E by capital R plus small r. So E is equal to V plus V dash. And we have written this one also again. V is equal to E by R plus R into V is equal to E by R plus R into capital R. Here V equal to I into capital R. V dash is equal to I into small r. V dash is equal to I into small r. And from this one, we also rewritten as R is equal to E minus V by V into capital R. Then we have written one more formula, that discharging equation, that is V is equal to E minus IR. So whenever we use the term closed circuit, you must be ready with this total information. The total information you have to be ready, beta. So this is the information about closed circuit. So these 5 points you have to keep in mind whenever the term closed circuit is mentioned. So at I is equal to E by total external resistance plus internal resistance. Total external resistance plus internal resistance. Like that I can write. Now I am taking here. This is the discharging equation. Remember, this last equation we also call it as discharging condition. This is discharging. So here you observe once the direction of current. Outside the cell, it is going from positive to negative. Inside the cell, current is flowing from negative to positive. Inside the cell, current is flowing from negative to positive. Outside the cell, positive to negative. Outside the cell, positive to negative. Inside the cell, negative to positive. Like that, current is flowing here. Now, what is happening? I have taken the direction of current inside the cell is from negative to positive. Suppose charging. Now we are going to discuss about charging situation. What is charging condition means? This is our cell. of EMF E and internal resistance small r. Now, I am connecting this cell to an external source. In your house, you will find inverter. What the inverter will do, beta? Inverter will charge. First, inverter is charged. Because of inverter, we are able to cut current. So, how you are charging the inverter means this is external source. From our current, we are charging the inverter, and inverter is giving the power to us. So now this is some external source. From external source, current is coming from positive terminal and enters into the cell like this, and again goes towards negative terminal. So external source it is. Now the potential difference across the cell. What is the potential difference across the cell means here? Generally, in discharging, what we observed, V equal to E minus IR in discharging. In discharging, current is traveling from where to where? Current is traveling from inside the cell negative to positive. Negative to positive inside the cell. But now, how the current is flowing? Current is flowing inside the cell from positive to negative. Positive to negative is going in opposite direction. Opposite direction, current opposite direction means actually we'll get here V equal to E plus IR. For discharging, what you have written, beta? Discharging, we have written it as E minus IR. Here in the plus, I have written here first E minus IR for discharging. But what happened here? It is charging. Current is flowing in opposite direction inside the cell. How current is flowing? Positive to negative. Positive to negative. So positive to negative current is flowing means opposite direction inside the cell. So we use here plus sign. We use here plus sign. So V is equal to E plus IR. This is the charging equation. Charging equation. Charging equation is V is equal to E plus IR. You have to remember direction of current. Inside the cell, current direction from where to where? Positive to negative. Inside the cell, positive to negative charging. Negative to positive current is flowing inside the cell. It is discharging of the cell. Discharging. Difference between charging and discharging. I hope you understood. Next. Let us see now open circuit. Open circuit. What is open circuit? What is open circuit means? Here I am taking one external resistance and a cell is there here, and internal resistance is one, and there is no connection here. They are disconnected. They are disconnected here. This is a cell of EMF E, small r, and this is capital R. And now current, what will happen? Current always flows from where to where? Positive terminal to negative terminal. But as the wire is disconnected, what we can say, current cannot flow through the circuit. The wire is disconnected means current does not flow in the circuit. As current is not flowing in the circuit, what is discharging equation? V is equal to E minus IR is discharging equation. Discharging equation. But in discharging equation, as I value is equal to 0, I value is equal to 0. Now what should I write? V is equal to simply E. I is equal to 0 means V is equal to E. This is the open circuit, then we can have the potential difference is equal to EMF. In open circuit, potential difference across the external resistance is equal to EMF of the cell. That is open circuit. Open circuit means somewhere there is disconnection somewhere like this. As disconnection is there, current will not flow in the open circuit. Definitely, current has to flow. We need the completely closed. Somewhere disconnected, current cannot flow through the circuit. So this is called as open circuit. That is the information about open circuit beta. Now let us check what is the next one. Here open circuit, we discussed about closed circuit in the discharging as well as charging. Now open circuit. Let us see about what is short circuit. Short circuit. Short circuit means directly connected. That is, suppose I am taking, this is the positive terminal EMF and internal resistance, and here what happened, beta? I am taking one external resistance, and suppose we have one more wire directly connected like this. So short circuit means the wire is directly connected to that point. So when the current is flowing here from here I, so what happened is current is coming from here is I, and from positive terminal. Always you know current flows from where to where? Positive to negative. So current is coming here. Here the wire, that means we have made one direct connection like this from here to here. So we can also say this connection we didn't mention any resistance. That means resistance is zero. Current always chooses the zero resistance path. So current always chooses the zero resistance path and will enter to the cell. That means current is not flowing into the external resistance. So when current is not flowing to the external resistance value is zero. Short circuit means the external resistance is short circuited. It is removed. The term you can also say it is removed. The current is not entering into the external resistance. Why, sir? Here and here, potential will become same. If you connect a zero resistance wire like that, the potential across the ends are same. The potential at this point will become same. If potentials are same, current will not flow. Current has to flow. We need potential difference. We need potential difference. Here resistance is there. Across the ends here and here, potential is same. So current will not enter. As a current is not entering into this path, automatically current directly will go through this one and will enter into the negative terminal. This is the information about short circuit. In short circuit, external resistance is eliminated. So what is the formula here? What is the formula means here? E is equal to I into capital R plus I into small r, as capital R is equal to 0. Capital R is equal to 0. Simply E equal to IR. So whenever you say short circuit, I is equal to E by R. I equal to E by R. So in short circuit, external resistance is 0. In open circuit, current is 0. Like that. I hope you are clear with this one also, beta. Next, we have to know about some important point related to internal resistance. Internal resistance. Internal resistance, when we are taking, it is the opposition to flow of current through electrolyte. Opposition, we told it as opposition to flow of current through electrolyte. Current through electrolyte of the cell. Electrolyte of the cell. Electrolyte of the cell. So here the opposition to flow current through the electrolyte of the cell we told. Suppose if you have mentioned it is an ideal cell. What do you mean by ideal cell? Means the internal resistance value is 0. Whenever you mention ideal cell, remember ideal cell means internal resistance is 0. They mention ideal cell means the opposition to flow of current through electrolyte is 0 for ideal cell. Ideal cell. So you have to remember this point. If they mention ideal cell in that problem, you have to take small r value as 0. Small r value is 0 if it is mentioned ideal cell. Next, now we have to observe how cells are connected in series. Cells in series combination. Cells in series combination. So now you observe carefully here. I am taking one cell like this. This is the positive terminal, negative terminal. Another cell, positive terminal, negative terminal. Like that. So on. The cells are connected in such a way that positive and negative are connected one to other like that. And this combination is called as series. And this is external resistance. EMF of first one is E1, R1, E2, R2, and so on up to this is EN, RN. Like that, N cells are there. What is the current through this one means? Current formula starting we told that I is equal to, this is a closed circuit. So E net by R plus R net. I is equal to E by R plus R we wrote. But here we have to take E net because so many cells are there. E net by R plus. So internal resistance are also, you can observe here R1, R2, R and so on like that. So R net internal resistance. So now the question is, what is net EMF? The net EMF is equal to, net EMF is equal to, series means E1 plus, E2 plus, so on up to En for cells. Cells in series. So the cells in series combination E1 plus, E2 plus, so on up to En. All are identical. So not identical. All are not identical. We can write like that. Then what is R net? So R net is resistances related to the resistances. These resistances are also in series because cells in series, resistances are also in series. So what we have to write here, R1 plus, R2 plus, so on up to Rn, Rn. I can conclude the current is equal to E1 plus, E2 plus, so on up to En by what we can write here, R plus, R1 plus, R2 plus, so on up to Rn, so on up to Rn. Like that I can write the formula for current, So this is the current formula when we are taking the external resistance connected here. How current will flow? From positive terminal to negative terminal, the current is flowing like this. So I value, this is the formula for electric current, Please observe carefully what is the current formula we got. I is equal to total EMF by external resistance plus total internal resistance. External resistance plus total internal resistance. Like that, I can write the formula here. So this is a series combination. Remember, series means negative connected to positive, negative connected to positive, again negative connected to positive. Such type of combination is called series combination. These are non-identical cells. Suppose I am taking identical cells in series. Identical cells in series. What do you mean by identical cells means? Identical means internal resistance and EMF are equal. So I can write E1 is equal to E2, so on up to En is equal to E. Let us say it is E. Let us say it as E. So all the cells EMFs are equal as well as all the internal resistances are equal. Let us say it as small r. Let us say it as small r. So from this information, what I can write totally, how many are there like that? N cells, identical cells totally. I can write N identical cells in series, N identical cells in series. Now what is my formula here? E net is equal to, how many are there like that? N are there. N cells are there means I can write it as Ne. Similarly, R net is equal to R plus, so on up to N cells are there like that, all are in series, N naught. So what is our main formula? I equal to E net by R plus R net. I is equal to E by R plus R net. From this, I am getting the formula for current for identical cells as I is equal to Ne by R plus NR. Very important for objectives point of view. We are using oftenly this one in problems. So remember this formula beta I is equal to NE by R plus NR. This is for N identical cells in series. N identical cells in series. Now, let us observe next important point, that is wrongly connected cells in series. Wrongly connected in series combination. Wrongly connected cells in series combination. How we connect in the wrong way in series combination? Let us observe carefully here. Series means I told positive, and this is the positive terminal, negative terminal, and again positive terminal, negative terminal. Suppose I am taking some 5 cells, positive terminal, negative terminal, positive terminal, negative terminal, positive terminal, negative terminal, 5 cells like that. But one cell I connected reverse. You observe carefully here. The last cell what I did here, I connected in reverse connection. You observe carefully the last one, negative and positive I connected. So this is the wrongly connected cell, means here you can observe carefully. This is generally we have to connect in all these things. How I am connecting? Negative to positive, negative to positive, negative to positive. But in one cell I connected negative, 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 or positive, positive. If you connect, that is called as wrongly connected cell. That is the wrongly connected in series combination. This is external resistance. Your majority cells are in one order. Let me take the current is in this direction flowing here, and it is entering like this. Now, here one cell is connected in opposite. One cell is connected in opposite. This cell is connected in opposite. Negative to negative. Negative to negative. Or positive to positive. Like that if you connect, then we call that cell is wrongly connected. Now observe carefully beta here. What is the E net value? E net value means here I can write E plus. Total how many are there? E plus. E. Total you can observe here 1, 2, 3, 4, 5 are in series. This is also in series, but reverse connected. Reverse connected means I have to use the term here minus E. So EMF has direction. So negative to negative connect, it will have E minus E. It is a scalar quantity, but still it has direction. So if you connect in reverse, we have to use minus sign for cells, because even it is a scalar, EMF is having direction. EMF is scalar, but it has direction. So now, because of direction, we got this as a minus sign here. Next, let us see now. What about R net? R net is equal to R plus, R. Here, when we are taking here, we didn't bother about the negative or positive sign. Here, the internal resistance is a scalar, as well as it don't have any direction also. Simply all are connected one to other. Such combination is series. It doesn't bother negative or positive cell connected. Resistance does not bother about cell connection. So all the cells are in series. How many are there? 6 are there. Now, what is my formula for electric current? Or what is the net EMF value? Net EMF value is 4E. Net EMF value is 4E. Net internal resistance value is here. How many are there? Total 6 are there. 6R. So I can write it as 6R. So I have found that is EMF. Net EMF is, what is net EMF beta? Net EMF is 4E and net internal resistance is 6R. So this is the information what we got. I hope it is clear here. Cells in wrongly connected cells means negative connected or positive connected. Such type of combination is called wrongly connected cells. In that, we have to take this one is reverse. Reverse means minus C. This last one I am taking it as minus C. So I got net EMF 4E. But net internal resistance, it does not affect with the combinations of cells. So simply R plus R plus R 6R. So now I hope you are clear with this idea about wrongly connected cells. Let us observe now what is the net EMF here. I is equal to, my formula is I is equal to E net by R plus R net. So I can write it as 6E by R plus, that is how much here? Sorry, 4E. I have told you just now it is not 6E and it is what? 4E. 4E I have mentioned 6R. This is the net E current formula 4E by R plus 6R. So for wrongly connected cells, generalized formula I am writing. I is equal to NE by, I can write this wrongly connected cells generalized formula like this, beta. You remember? N minus 2m into E by R plus NR. This is generalized formula for wrongly connected cells. N is total number of cells, and M is equal to number of wrongly connected cells, number of wrongly connected cells.